We are live. Start recording now, actually.
Sure. Can you mute? Hi, everyone. Welcome to this session of Let Us Talk It webinars. We are extremely excited to have you again with us today. And as you know, today is Wednesday and we have our technical session today. So all technical people, please join in if you have not joined yet. And welcome all the attendees who join in on Zoom, on Facebook, YouTube, LinkedIn, anywhere. And the best way of interaction is through comments. And if you can give your comments, feedback, or let us know what other topics you want to hear in the technical field or any other area, please email us at webinar@letustalkit.com. And we do these professional work and life related webinars every Tuesday, Wednesday, Thursday from 12 to 1 p.m. EST. And we do our Let Us Talk It Youth series every Friday, which from this week will be changed to Saturday from 4 to 5 p.m. EST. So hopefully more youth and more parents can also can join the session and benefit from it. So we'll talk about that little later more. But for today's topic, we have Microsoft Azure Cloud, an overview, the technologies, and the migration specifically. And to talk on this topic, we have a very experienced guest speaker with us. His name is Kranti Asapu, and he is highly motivated technology person with passion for building rapidly growing and scaling solutions. He also has multidisciplinary skills with over 14 years of experience in software design, development, and products. Also, his experience includes SAP Cloud Analytics and his extensive consulting experience in building and improving user experiences by integrating data from products, platforms, and focus on scalable architecture development, deployment, application, and project management and support is some things that needs to be mentioned. And as far as his professional education is concerned, he has his discrete choice analysis from MIT, business analytics from HBX, deep learning specialization from deeplearning.ai, and many other machine learning courses. So let's hear from the person who is more knowledgeable in this field. And we welcome you, Kranti. Over to you.
Thank you, Jamil. So are you able to see my screen? Or?
Not yet.
Hope you are able to see my screen. Hello? Hello?
Yeah, we can view your screen.
Oh, okay.
No, just, yeah. Now it's only screen. Yeah.
Okay.
Thank you.
Thanks for providing me an opportunity to present, and that was a nice introduction, Jilan. And so in this 1 hour, I tried to cover as much as what is Azure Cloud and what all and overview of Azure Cloud and what all the services Azure Cloud has provided, and the migration path to migrate our on-premise environment to the cloud. So what is Azure? Azure is the Microsoft cloud provider. So the name for the cloud provider from Microsoft is Azure, and it has much more flexibility from the developer standpoint. It is very intuitive to use the cloud services from an Azure portal. You can spin on the virtual machines, or you can spin on the virtual networks and the services by using a front-end clicks, or you can use the PowerShell commands or Azure CLI. At the same time, it is much more consistent with an hybrid cloud in the sense whether it's an on-premise environment or it is a cloud environment. You can able to sync your data, or you can able to sync your services or the files from your on-premise to the cloud. It is much more consistent to compare it to any other cloud. So it is more consistent in the hybrid cloud environment as well as in the native cloud environment. And it has a more cloud native intelligent applications, whether it is your web application or uh, uh, embedded your web application with your AI or machine learning. So Microsoft Azure has a capability to intelligent your application in different ways, as well as the security standpoint. Microsoft Azure is much more secure and it has more certifications than any other cloud provider is. So coming to what is cloud computing? Cloud computing is the delivery of a computing services over the internet. That means you are not having your on-premise bare metal servers. You can rent your servers from the cloud vendor, which is a Microsoft, and your networking completely secured by using Microsoft virtual network services, as well as the storage, which is Microsoft storage services like a blob files, tables, and Microsoft storage services, as well as analytics from the computing. Whatever we are doing it from the services standpoint, whether it is a compute, whether it is a network, whether it is a storage, we can see a complete overview of the monitoring of the services, how much we are spending and how much our services are really scaling up, scaling down, or what is our scalability, flexibility in our environment of complete end-to-end we can use through the analytics. And coming to why we use this cloud. So why we are going to a cloud? Because we have an on-premise environment, we are very good and we are working from years. Why we want to use a cloud? Because it is providing the same capability like whatever the on-premise services are doing, but why we are going to move to the cloud. Example, if you take the compute, if you see on and off of the workloads, by taking a use case of if I am having an enterprise application and I am using a report every week of my complete in a month, I am going to use only 4 times and 20 users are using this particular report. But I have to maintain a database for that, and I have to maintain an application for that, and I have to maintain a compute for that. But to maintain that, and I need to pay for that whole year, because this is using monthly 4 times and 48 times in a whole year. But I have to maintain for my complete 1 year. But even if this, we know this particular report or this particular job is running only for a week, why I need to spend a compute for the whole another 5 days, or I need to spin on my services whenever I can see a spike in my workload. So these kind of things which are really complex in the on-premise environment. But whereas coming to the cloud environment, which we have seen in, we can spin off the servers, we can, whenever we are going to require it, we can spin on it, and as well as whenever we can really have that service in, we can go for it, or otherwise we can switch off those servers in. So in that kind of flexibility, and whereas a scalability, and we have a latency when we are going with the cloud, whereas with an on-premise server, we are spending our capital expenses upheld. That means if I need a 2 terabyte of a space, I need to provide the 2 terabytes of space for the whole year. But only this 2 terabytes of space is using hardly 12 times a year. So in that sense, whether we can go with pay-as-you-go method, or we have to go with purchasing upheld and keeping on this investment for the whole year. So in this type, the cloud is the best to use. And it is very growing fast, in the sense if I have to innovate new things, if I have to introduce a new application into the organization, then cloud is the one which we can provide it very quickly and very fastly. And here is the cloud computing stack. If you see, we have an infrastructure as a service, and platform as a service, and software as a service. So what are all these three differences in the computing stack? If it is a packaged software on the on-premise environment, you are responsible for networking, storage, servers, virtualization, operating system, middleware, runtime, data, and applications. Everything which in-house you need to maintain it, from the bare metal servers to the application which you are running on your premise. But whereas with an infrastructure as a service, initially any organization will go with infrastructure as a service because this is having an uh, uh, maybe it is an enterprise application, maybe it is initial migration, they will go with an infrastructure as a service. Later we move to platform as a service, then any off-the-shelf software products, then we can use a software as a service products like Office 365. So infrastructure as a service, what Microsoft is Microsoft managed services are virtualization, servers, storage, and networking. That means your network, your virtual machines, and the server storage is managed by your Microsoft. But you are responsible for the operating system, middleware, runtime, data, and applications is the which we need to manage it. Whereas a platform as a service, which runtime, middleware, and operating system is also managed by the platform, which is managed by the Microsoft or by the vendor, whether it is AWS or the Google Cloud. So managed by the vendor, but only we are responsible for the data and application. So platform as a service, some of the applications will go with the platform as a service. That means we are only responsible for the data and application. That means we have a less burden, and we can scale up or scale down our applications much more easier than infrastructure as a service. That means we don't need to worry about for the patches, upgrades of the operating system, or patches of the application, everything which we no need to worry when it is moved to a platform as a service. When it is a software as a service, we are no need to maintain about application or the data. Everything is maintained by vendor. Like example, Office 365. So we have a public cloud, private cloud, and hybrid cloud. So we'll go with what we need to know is what is a public cloud. Public cloud is owned by cloud services or a hosting provider. That means we are using a set of servers from an environment which is from the vendor, which is not dedicated to us, but they can used by any other service, any other organizations. But we are using a services from Microsoft, which can be used by anyone. That is called the public cloud. It is not dedicated to us. Whereas a private cloud, which is dedicated to us in a data center, that means in Microsoft data center, which is specifically dedicated to our organization, then that we are using is a private cloud. That means the same capabilities, whatever there in the public cloud we have in, but it is dedicated, the data center or the data center rack or the machines are dedicated to only to our organization, which is the private cloud. And hybrid cloud is both public and private cloud. Some organizations will plan both. Some of the applications are run on public cloud, some of the applications are run on private cloud. That means which are reserved instances or spot instances, which are really required only for me, not to any other organization. If I reserved my instances or if I have my spot VMs ready for my organization, that is only dedicated to us, not to use by any other organization. And here we have, as mentioned, infrastructure as a service. Infrastructure as a service will rent servers, network, which is security, firewalls, and data center physical plant buildings, which is called an infrastructure as a service. That means virtual machines, storage, networks are maintained by as infrastructure as a service. Whereas platform as a service, which are storage, servers, and data centers, and as well as operating system and development tools are also maintained by uh, platform as a service uh, cloud provider. Whereas software as a service, which we no need to maintain anything from our end, we are just using from an internet browser, we are using that application, and we no need to worry about the scaling up or the patches or any of those application or the data level, which we can use completely from the browser. So these are all software as a service. In cloud service, if you compare these IaaS, PaaS, and SaaS, it's so-called, and the most flexible cloud service, you can configure and manage the virtual hardware for your application. So why we call it as a virtual hardware? The virtualization layer in an infrastructure as a service, we can maintain those virtual machines on top of the bare metal service. Whereas platform as a service focus on the application development. That means we need to worry only on the development of the application. That means we need to work on our data and as well as the application. We don't need to worry of the patches of this application, and we don't need to worry about the upgrades. We don't need to worry about maintenance of the operating system or the application. That completely taken care by the vendor. Whereas software as a service, pay as you go, how much you are going to use that service, not even the application, not even the data, whatever the software vendor provided, we are using that application. So we have no need to write our code to the application. So completely as a service. Like if I give an example, this is your IaaS is example as a car, renting a car and an Uber. So you can take that comparison, popular example of renting a cars. And here are the cloud benefits. One is the high availability, scalability, and global reach, agility, disaster recovery. So the cloud, whenever we are, example, whether it is in US, whether it is in Europe, whether it is in Asia Pacific, or it is in India or in China, high available servers, whenever we can operate our machines, organizations can operate their, serve their clients, they can, the servers are readily available and the system is always up with a high availability. That means it's a global reach. That means whether it is in US, the servers are near to US data center, and we can enable the geo redundancy using, so that we can have our services, or we can have our applications with a high availability. Whereas the scalability is also high. Example, my application have a heavy workload, then I can easily scale up my compute power to that application. And whereas a global reach, as mentioned, it is not only specific to a particular region, it will be around the world. You can run your application around the world without any latency, without the low latency. Whereas the agility, and then the disaster recovery. And the agility we have whenever we can turn up, or whenever we can think of applying our new logic or applying our new capabilities into the environment, we have that agility provided by the cloud native application or cloud native services. So that kind of agility was there with cloud compared to our on-premise environment. Because if it is in an on-premise environment, what we need to do, we need to uh, gather our infrastructure, and then operating system patches, and then operating system has to be ready, then the code has to be ready, then you need to deploy, then we need to make it, test it, and then we need to migrate into the production. Whereas with the cloud environment, we have the capability of DevOps completely, it's on the cloud, and we have that kind of agility to from an idea to going into a production. And coming to disaster recovery, like in our on-premise, we have to maintain our servers, whether it is in East Coast, we have our production servers are maintaining, West Coast, we have our disaster recovery. That disaster recovery capability is also provided by cloud, not only in one location, when we can have choice of any other location in the cloud. And whereas the fault tolerance, example, if your servers are in the same rack, if that has gotten failed, immediately it will take up to the next rack, and that is the fault tolerance. And the same with the elasticity, we have the elastic capability to expand, swing on, to decrease our, whenever we have a high velocity of volume of data is coming in, we can increase our capability, and whenever we have a less time in, we can decrease our capability. That kind of elasticity was there with the cloud, whereas it is not possible with the on-premise environment. There is a custom latency capability and predictive cost considerations. We can predict our cost based upon the cost management tools and monitoring tools which we have embedded in our cloud environment, whether it is in Azure Monitor or Azure AD Connect Health, different monitoring tools which have in the cloud so that we can have those kind of benefits in the cloud. And coming to the security, one of the highest security provided, not only for the data centers like fencings and the authorizations and authentication of the people who are coming in, and not only that, but whereas in data transfer from one environment to another through wires, cables, we have an end-to-end encryption provided by the cloud. And coming to the backbone of this network is Azure has more data centers than any other cloud provider has. So if you see, these are all the available regions. If you think it's covered almost the complete globe, and they have around 54 data centers around the world, whether in Europe, North America, Asia Pacific, India, South Pacific, South Asia, and Africa, and Latin America, and Australia. So they covered all the regions, so we can access our application anywhere in the world. So coming to Azure resources. So the main, to support these cloud environment, these are all the main resources. There are other resources as well, but these are all the resources components which supports cloud: virtual machines, storage accounts, functions, app services, SQL databases, and virtual networks. So virtual machines, as mentioned, it will run on the bare metal servers. This will run to compute our support our application. It's like our computer. If you think virtual machine, it will like a computer. It has a CPU, memory, and it has different SKUs. These SKUs are whether it is 8-core CPU and 64 GB RAM and different hard disk we can select in. So that kind of capability was there in the virtual machines, and we have a different SKUs with M series and high performance cloud virtual machines to the low performing for our dev test environments. We can use those virtual machines, but with the high performance cloud, either if you are going to use machine learning or deep learning, then we can use very high perform virtual machines. And coming to the storage accounts are nothing but a managed storage, whether it is a blob storage or Azure files or data stores and tables, which are in the storage account. Coming to a virtual network are nothing but connection of an network from your on-premise or from site to site, or which is from an on-premise to the cloud, or from the client to the cloud, or from cloud to cloud. So virtual networks will help support to connect the premises. And coming to app services which Microsoft Cloud provides has a capability which has with an HTTP service and REST APIs. It will support the app backends and as well as the mobile backends. It will support some different languages like Python, Ruby, PHP, .NET, ASP.NET. It will support and there supports multiple languages on the app services. And not only that, it supports the DevOps capabilities with using the app services. And same and the databases and SQL databases. SQL databases is mainly consisted of relational databases. It has more consistent data, and it will supports the asset properties. SQL, Microsoft provided SQL database, and easy to migrate from on-premise to SQL database. Whereas Azure functions are nothing but a small piece of code which run on a cloud environment. We are responsible only for the cloud infrastructure, everything taken care by the cloud environment. But Microsoft Azure functions is nothing but a serverless compute. So these are all the platform as a service. Platform as a service. If you see the complete stack of Microsoft services which are provided from the security and management standpoint, Azure Portal is the one which platform which we can spin on or turn, or we can configure everything from the Azure portal. And Azure Active Directory is nothing but the Active Directory which we are seeing in our on-premise, the same Active Directory for the maintenance of the domain and for the users, access, roles, everything can be maintained from the Azure Active Directory. And from Azure itself, we can authenticate multi-factor authentication for any app. If I want to do a multi-factor authentication, either from my mobile, my authentication from my mobile, or from email, or OTP, or any sort of code which we can provide to access into our systems, we can additional securities can be enabled through multi-factor authentications. Same with an automation, we can automate multiple process with an automation capabilities provided by Azure. And Key Vault is nothing but we can secure all our certificates and keys in the Azure Key Vault. And it has a more flexibility to integrate with different services, whether if it is an application has to be authenticated or my database keys has to be secured in the Key Vault, we can keep in the Key Vault. At the same time, it integrates with the same with an application with an REST APIs. And the same with the store marketplace, we can, if we want to buy any of the new services, once we have the licenses in and all, then we can buy from our store and we can turn from the marketplace. And the same with VM image gallery and VM depot, all the images which we can store from virtual machine, like to virtual machine scale set. If we want to scale up our virtual machine, we want to build a scale set, then we can keep create from an image and use that image, and we can scale that virtual machines. And the same, and coming to the compute, it has a cloud services, service fabric, batch, and remote app. That means we can completely manage our compute services from the cloud services, and we can turn our Windows applications from a remote app. Like that means it is a remote desktop, how we are connecting to our virtual machines, or we need to connect through a VPN, we can use a remote app. And as well as a batch and service fabric is nothing but your on-premise and cloud, which can be managed from one single center, which is a service fabric. And coming to web and mobile, web apps, API management, mobile apps, logic apps, notification hubs are the services which comes under web and mobile. Web apps is nothing but which comes under as an app services. Web apps is particularly specifically for our web applications, which supports it supports and as well as it turns our virtual machines, and it can enable the scalability latency from that application itself. It's a complete stack we can use, and we can write our application code either in Python, Java, or Node.js, or PHP, ASP.NET. The web applications will support that, and we can use that web application very easily compared to our other applications which were built in our on-premise environment. And logic apps is an stream. I mean, it's a workflow. Example, if I have one particular service, okay, this service, if it got approved, then this email has to send to this particular person. If that email has to send, then it has to go to this particular function. Then logic apps will enable that workflow. We can go with logic apps. Coming to the notification hubs is a service which we can notify to multiple users at the same time. So that capability provided by the notification hub. And to write our logics and to a development toolkit, then we have our development services. Azure has provided a Visual Studio, which is tightly integrated with the cloud. That means you can write your code on the cloud, and you can directly integrate into the cloud environment using Visual Studio, Team Project, Azure SDK Kit. Either you can use Visual Studio or Azure SDK. And from all this, we can enable our application insights from our development services itself. In the sense, application insights will enable us to write our code for the application to get, okay, how is my application is doing, how much services from based upon the logs, we can write our logic to get and more insights from the application. What is the health of my application, where it is taking time, how the performance of the application. So we can, everything can be enabled from our application insights. And coming to the integration part, we have a storage queue, service bus, and we stock services. The same whatever we are seeing in our cloud, which are in the on-premise, we can do that with an integration with the cloud. It not only supports these queues, it supports the third-party queues like MuleSoft or TIBCO services or any other middleware services. It will integrate it. Integrate to the Azure. And coming to the media and CDN, media services are there for media streamings and all, and whereas the CDN, which is the content delivery network, which mainly used for our streaming services, and which we need to keep our network on the edge, then content delivery network will really helps, and that's where media and CDN are the ones which are stream or which are mostly for the videos, photos, which we are going to use this service. Depends upon the organization, their business, they are going to use these services. Whereas coming to analytics and IoT, Internet of Things and analytics, we have a different set of services, but these are all some of the ones mainly going to use like machine learning capability. It can, without writing any code of machine learning, we can turn off our AutoML, Azure AutoML services and HD AutoML services, and we can do predictions, recommendation engines. Every algorithm is available for the supervisor learning, unsupervised learning, which not only those and the algorithms provided like k-means clustering, classification algorithms, everything was provided by Microsoft, and we can also customize those codes once we upload the data. We can tune our parameters. We can run and deploy, train and deploy those algorithms into production. We can enable recommendation engines, we can do time series analysis, we can do anomaly detection. So all these services are provided for the analytics capability using machine learnings. And whereas HD Insight is it leverages the Hadoop capabilities, Hadoop, Kafka, Hive capabilities by using HD Insight. And coming to the event hubs is mostly for the streaming. Multiple streaming applications are coming into our event hubs from there. It's like Kafka. Event hubs is and Kafka for cloud, for Microsoft Cloud. And coming to a data, it supports multiple databases, both SQL and NoSQL databases. It's not only SQL databases like key value, document database, graph database. It supports like Cosmos DB, MongoDB, Neo4j, which is a graph database, and Redis cache. So all these databases supported by Microsoft Azure Cloud, and it has an SQL database, SQL data warehouse, which is a relational schema oriented database. Whether it is an on-premise and migrating to the cloud, it has the same capability, which has a seamless migration happens using data migration assistance tools. And whereas Redis cache is an in-memory compute, in-memory database, which will store a lot of application data, which will readily available for your application to access frequently used content, which is sitting on the Redis cache, which is key value store in Redis cache, which is a NoSQL DB. And for the document DB, MongoDB is the one which will support, and platform will tightly integrated with the MongoDB. And for columnar search, Cassandra is the one which the DB which supports from Azure service. And for the tables and SQL data warehouse, we know that it is a database which we know relational databases. It will have the compliance of asset properties. It will support all the asset properties. Relational database, mostly financial applications are stored using SQL database. So it will support different types of databases, whether it is in structured, unstructured data, whether it is a structured data, it will support in this environment. And coming to hybrid operations, Azure AD Connect Health is the one which will support both on-premise and on the cloud, which will have the connectivity tightly integrated with on-premise as well as in the cloud. Azure AD Connect Health will give our services, how our services running on-premise and as well as on the cloud. And Azure AD Privileged Identity is mostly just-in-time access, like privileged access given at a time whenever required for our developers and for the resources who are using the applications. And coming to the backup capabilities, that the RTO and RPO capabilities are there for the Microsoft Azure Cloud. So the backup will be taken of our database into either in the same region or in a different region. It will support the backup capabilities and operation management suite, which will completely analyze the operation management happening in the environment. Import, export capabilities from the data can be imported, exported in multiple locations and multiple areas, which will support by cloud. And site recovery, which mainly from when we are migration is happening, the site recovery is the one capability which we can migrate our services from on-premise to the cloud. Site recovery is the one which really helps in. And as we discussed, the compute, store, infrastructure services, compute, storage, and networking. And in networking, the main part is traffic manager, load balancer, and application gateway. These are all the load balancers which are supported by Microsoft. The load balancer is mainly from the layer 4 of an OSI model, like OSI layer has a different layer, physical data link layer, and networking layer, transport layer. The transport layer is the one for load balancer and for the traffic manager. And we have a session layer, presentation layer, and the application layer. And the application layer, application gateway is the one which supports the HTTP, HTTPS traffic, which is coming from our internet. It will route the traffic into backend pools, and from the backend pools, it will go to different virtual machines of our virtual network. And from there, it will go to an, whether it is web servers or it's an application server, from there to the database servers. And that's how the traffic was diverted, and it will have a capability of SQL injection attacks or DDoS attacks, or maybe different sort of security threats it will handle by these load balancers. Traffic manager is another capability of supporting multiple regions, not only in one region. It will divert the traffic from one region to another region. When we have a service which are managing heavily, example on East Coast, my traffic is heavy, then it will route the traffic to the central US. So that's how the traffic manager will help us to route the traffic by taking the front end pools and diverting it to the back end pools. And I highlighted some of the cloud services as in the previous one, which discussed. These are all the main or heavily used services in any organization as per the stats, but each and every service has their own capability. As we discussed, example, if you divide those services into AI and machine learning, cognitive services has vision, language understanding, and speech. So these services which are provided by the Microsoft. So computer vision, example, the facial recognition or image classifiers directly from our Azure service, you can enable it without writing any neural network logic in. And the same with the machine learning. We have different algorithms in machine learning, like we have classification algorithms or clustering algorithms. Every algorithm was supported by machine learning toolkit. You can use those tool, you can use and you can do those machine learning, run those machine learning algorithms on top of your data. The same with the bot service. The bot service is additionally provided by Microsoft, which helps to build your chatbots by using a language understanding. That means if you open a website, any of well-known website, automatically a chatbot will appear to get the service, or you can enable your chatbots in your organization by using these services uh, with a minimal technology stack and with a minimal resources, in the sense who are able to write a large set of code to convert that language into an structured language, how the bot service is providing. Not uh, uh, it's an structured, or we can pre-hard coded stuff, but bot services is using an language understanding. It will understand your language and reciprocate that based upon your training data, gives the particular results. So that's where the bot services are really useful from the Microsoft Cloud perspective, and the same with the Dialogflow and Amazon and any other comparative tools in other cloud environments. The Synapse Analytics is another analytics tool which combines both uh, big data as well as a data warehouse. On top of it, we'll do analytics using Synapse Analytics. Event hubs, as we discussed, event hubs are the use data processing, streaming the data into that event hub, and from there we can process into multiple areas. Event hubs are same with app services, Azure functions, and the compute, and the databases, and the development. Coming to the development perspective, Azure DevOps is a complete stack which provided from end to end, coming to the development to the production, and to manage it, operationalize it. It has Azure boards, and it will support the containers like Docker containers and Azure Kubernetes. Kubernetes is an orchestration for the containers. That means using a Microsoft microservices architecture. If you use those, then you'll know about much more about containers and Kubernetes, how we can scale up the systems and how you can productionalize the development and the testing. Once done, then how we can migrate into the production. And the same with identity and security, as we see in the Azure Active Directory, which has a full stack. You can enable access, you can turn off your access, and you can maintain access for users. And Azure Key Vault is the one maintaining the keys. So these are all the services which are maintained from identity and security, as well as integration, management and governance, media, migration, and networking and storage. And now going to the migration, and here now earlier in the previous slide we saw what are all the services which are there. In not all services are really required for the organization. Depends on the project, depends on the migration path which we have taken in, and what are all the applications which we are going to migrate into the cloud. That we need to analyze first, then we can use those services accordingly based upon the cost management, based upon the planning which we have done initially, then use those services. But not all those services which are really required for our organization or for our migration. So mainly the migration drivers are example, what are all the issues, or what are all the driving factor to migrate to the cloud are data center contract expiry and quickly integrate acquisitions, software hardware refresh, security threats, compliance, and application innovation, software support. In on-premise, if you want to innovate any of these new applications, if you want to turn our new capabilities, example, we have we enabled a chatbot in our web page, and we want to see our user feedback for our web page, how users are really interacting with our chatbot once it pops up, or whether our user is really interested to interact with our chatbot or not. But we can't wait, and we can't do that kind of experiment in production with by using on-premise. It has a lot of complexity, and as well as it has to purchase that kind of an application or the service earlier. But whereas with a cloud environment, we can see that kind of test can happen directly. Okay, I can test this particular uh, feature in only in particular region. Okay, I can select East Coast region, or I can select only one state. I can enable this thing only to these users, and we can see these users are really using my services or not. So in that sense, these kind of uh, uh, tests or these kind of application innovations are really easily and happens within cloud environment, whereas with on-premise environment it is very difficult. You need to purchase all those things, then you can. But from here to productionalize, it is very flexible, and it very uh, easy and scalable to do the things with cloud environment. Not only that, but from the capital expenses standpoint, we need to purchase IT expenditure, which is a capital expenses, which we need to spend upfront. We are thinking that we have a scope of, okay, I need to purchase like 10 virtual machines, but really required hardly these 10 virtual, because this is an buffer which we are giving in, but that is not really required for the whole year, but we are purchasing and keeping it, which is a capital expense. Those kind of expenses which we can really reduce it. And if we have any urgent capacity needs, normally which we can't really think about it, some of the after the pandemic we have seen very spikes and very huge demand for some of the products which we have seen, even those systems are not really capable to maintain those things, so they are maintained manually. So these kind of things happen. But whereas with a cloud environment, you can see those agents, and uh, we can address those urgent capacity needs. And same with the security threats, you have to always update your security stack, because as your security is not only from one service or one area, but it will be on multiple areas. So that kind of maintenance is really required for your applications. But whereas with the cloud, it's every time it upgrades, it's automatically enhances your application with these security alerts and security capability. And coming to the cloud adoption framework. So if you want to migrate from your on-premise to cloud, you need to have an adoption framework. First, you need to define your strategy, then plan, then ready your environment, then adopt it, then govern and manage it. So how you need to define your strategy? First, you need to get your leadership buy-in, then prepare a plan, what really give a value for your organization to once you migrate into the cloud. How much, what really gains in these applications are moving into the cloud means you have to show some benefit to the organization. If it is not, then there is no point in. So those kind of strategic and plan has to lay out. Then we have to show to the business stakeholders within the organization who are going to sponsor for the cloud. And then we need to plan for the migration. That means we need to see what are all the virtual machines we have in, or what is the network capability which we are, what is the bandwidth which we are using in, what is the firewall stack, or what is our databases which we are going to migrate in. So all these things which we need to plan in, and according to the plan, we have to purchase those things from the cloud vendor. Then we need to use those services from the cloud vendor. That plan has to be done, and then it has to be ready. That means once it is going to be ready, means we have to purchase the landing unit. That means we have to purchase the tenant. From that tenant, we can use the subscription. From subscriptions to the services, we can use services. At this point, we need to write the policies, the Azure policies. That means, example, if I'm the one who can spin off, the administrator who can spin on my virtual machines by mistake, then it should not chargeable. So that kind of policies, no one has to, without proper set of approvals, no one has to spin on the virtual machines, or no one has to spin on the databases, no one has to spin on anything. So those kind of policies has to set in place, otherwise it will be a big impact in the overall billing. So we need to see, and we need to adopt this framework in that sense, and apply these policies to and make a migration smooth, as well as to maintain and operationalize these cloud applications. We don't, if we don't want to see sudden surprises on the cost at the end of the month. And not only that, we can set some alerts on the cost, and we can do our dashboardings on top of services cost analysis. Everything was provided within that uh, cloud cost management toolkit. And coming to adopt, migrate, the first workload migration, and then we need to do initially, if we want to do for the first time, we need to do the POC, or if we want to do any of the new services which we are going to use, we can do a POC in the dev test environment, which is also in cloud, and we can use those services whenever required, and we can shut down those services whenever it is not required. So that kind of capability was there in migrate and innovation with adopt. And then govern, which is there is setting up some benchmarks. Okay, these are all the services which we are going to use. This is our budget. If we are crossing this budget, we have to rethink on what we are going to do. So that kind of governance has to be in place, and these are all the users which we are going to use these applications. That's kind of governance and set frameworks on these areas. The governance is very important, as well as is manage. The management is much more helps to optimize and to reduce our cost further. Example, initially we setting it up. Okay, after a few months we saw that, okay, these are all the services which are less used. Okay, we can reduce our cost in this area. I never seen any of these workloads are really running it. We can shut down those applications, or kind of an rehost, reframe, re-architecture, the 5 Rs, which are really helps to migrate, plan from our on-premise to the cloud. So here is a migration path, which is assess your environment, then migrate it, optimize it, and secure and manage the environment. Whether it is assess, for assessing, you have an Azure Migrate tool. Azure Migrate tool helps to assess your current environment, and you can give it. It will give you a cost once how it migrates. Once these are all the, if you are having a virtual machine, Windows virtual machine, you can convert it into a Linux virtual machine, and what are all the CPU CPUs which we need to use, or how much cores, and what is the RAM memory which we can use. That and all, everything will be assessed by Azure Migrate. And the same with the data migration assistance to data migrate it to the Azure SQL database. These are all the services which helps to assist us in assessing the environment. Whereas with a migrate, once assessing is done, then we need to migrate our on-premise environment to the cloud using ASR, Azure Site Recovery. Then we can migrate our on-premise environment to the cloud. Then we have an optimized the Azure Cost Management tool will optimize it, how much services are really using in based upon the logs which you can, and this service is this much cost, and at this time this much cost, everything maintained by cost management. Secure and manage Azure security, and as mentioned, the backup, monitoring, security center will monitor who are logging in, authentications, authorizations, everything will be done on security, secure and manage. Common migration projects are Windows Server, SQL Server, Linux, and I think I'm just checking out the time. Okay. And dev test, specialized VMs, and VDA. And SAP is the one which common migration projects infrastructure has migrated to cloud environment. SAP needs and use set of virtual machines, which are M series or E series virtual machines to run on SAP. And okay, so this is the compute service, how we need to choose the compute service. Example, I have a web application, but how my web application, how I need to choose in migrate. If you see lift and shift or cloud optimized, then I need to migrate to, if it is do really a full control, then I will go with a virtual machine. If it is a cloud completely optimized, then I will use high performance cloud workloads, then I will go with an Azure batch. If it is a microservices architecture, then I will go with an container instances and Azure Kubernetes services. If you see here, fully orchestrated, full-fledged Azure compute service, then it will be an Azure Kubernetes and containers really helps in, which is a microservices architecture. And coming to a basic web app, if you see, this is a basic architecture of completely using Azure native solutions. Front door, which helps to route the traffic to another regions. As cloud data network, as mentioned, images, videos, and everything will be there in the cloud. Uh, Content delivery network from the blog, from the web app to the queue. Functions will trigger to the SQL database and SQL search to the Cosmos DB, Redis, Kaki. This is how normally any NTR web application architecture which you have seen in. So from there, this is a reference. And then thank you. And we have, sorry, I'm running out of time. And we have a few minutes to questions. Thank you.
Yeah, thank you so much, Kranti. Any questions from anyone? Chandu, what is your take?
Yeah.
Anything
Hi,
new?
Jilan.
Yeah.
Yeah, actually, thank you so much, Kranti. It's a very information. It's like clean, simple, clear thing about cloud computing. And yeah, I would suggest this webinar for any learner who want to start the cloud computing course kind of thing. This will give the complete idea about what is cloud computing and Azure thing. It was very, very neat actually. I love the presentation. And actually, I need a copy for the copy of this presentation.
Okay, yeah, sure. Thank you, John.
Yeah. I know some of the Azure web services, but I learned new about this cognitive services and bot service. Yeah, surely I will explore into that. Thank you so much, Kranti.
Yeah, you can explore into Azure Docs dot Microsoft.com. So you have very in detail a walkthrough of the application to create it, and you can take 30-day free $200 credit Microsoft Cloud. Yeah, you can use those.
Yeah, thank you so much, Kranti. That was a very good webinar. Really enjoyed it. Yeah, thank you so much, Julian, for this
Thank you.
very good topic actually for learners kind of like me and everyone. Thank you.
Absolutely. I totally agree. And his calm and composed nature also, I think, everything he's explaining good stuff. I mean, some difficult stuff, but it's everything in a very soft way. So, I mean, definitely it should stir. If anyone wants to know more, please do let us know. At emailing us at webinar@letustalkit.com, and we can take it forward as well. And just to let you know that since we do these webinars every week, so we have tomorrow also 12 o'clock, 12 p.m. EST. The topic for tomorrow is alternative medicine, universal energy. So are you ready to welcome universal energy medicine into your life? A unique topic, something different. Please join us tomorrow to know more about it. And then we have the Let Us Talk It Youth Series Youth Webinar this week on Saturday from 4 to 5 p.m. EST. We'll see you there. And the topic is books. The ones that you like, why you like or love books, and what benefit you get or you don't get. So that's another interesting topic which youth are working hard on, and we hope that you will enjoy that as well. So any more questions? Any from YouTube, Facebook? If not, then thank you so much, Kranti, for your time, efforts, and making us understand the basics. Thank you so much.
Thank you. Thank you, Jill. Thank you.
Thank you. Thank you, attendees. We'll see you tomorrow. Bye.